everyone, welcome to 6.4 row reduction method. This is a different way of reducing or solving matrices. And so what we're going to do is we're going to look at an augmented matrix. This is a matrix, three matrices we could use to write and get a solution matrix for x, y. We can rewrite this as an augmented matrix. This is what an augmented matrix looks like. It basically gets rid of this, and then we just include it all into one single matrix. So we would have 2, 1, 5, 3. And I've seen it a couple of different ways. You could either have like these little dashes, and then you'd have your solution matrix of 5, 13, and have it all be one matrix. The other way that I've seen it is that you just have this line right here. So it's just a single line. Either way is okay. It doesn't matter if it's dashes or dots or just a line, as long as there's a separation between this half and this side. Okay, so what we're going to try and do is, using this augmented matrix, we're going to try and do a row reduction method. So this method, what it does, it tries to get rid of some of these numbers in here by, and I'll show you how in a little bit, so that way we end up with just one single number in each spot over here. So we would want to try and reduce it. So maybe you could divide everything by 2. So if I divide this by 2, divide this by 2, divide this by 2, I might end up reducing this down. There's some steps that we can do. So it reduces it down into something called reduced row echelon form. So reduced row echelon form basically means you have ones along the main diagonal and zeros everywhere else. So if it's a 2 by 2, and we have this dashed, and let's say it was 3, 7. Reduced row echelon form means that this one is a 1, this one's a 0. So that tells you that this, if we're talking about, remember in the equations, this would be x's and these would be y's. That means that x would equal 3, all right, and y would equal 7. All right, so row reduction method is a way to get to this point. Reduced row echelon form is in this form. All right, so that means that it is ones along the main diagonal this way and zeros everywhere else. So if we had 3, let's say we had a system of 3, it'd be 1, 0, 0, 0, 1, 0, 0, 0, 1, and then we'd have our separation, and then we'd have some numbers after that. All right, so let's look at, here are the things you can do with rows. The first thing you can do is you can multiply all the numbers in a row by anything besides 0. So if I want to do that up here, I could multiply everything on top here by, let's say, multiply this by 2. So that would make this row, instead of 2, 1, 5, it could be 4, 2, 10. All right, so I just multiplied that top row by 2. So you can multiply or divide any row besides 0. If it's 0, then it cancels everything out, and it's not going to be helpful as far as solving a system of equations. 2, you can add all the numbers in a row to corresponding numbers in another row. So that means if I wanted to, I could add these two, or I could add these 2 rows, and so let's just replace it with a different row. So let's say I want to replace row 2. So it would be 5 plus 2 would be, we'd have 2, 1, 5. And then I could add 2 plus 5 would be 7, 3 plus 1 is 4, and 5 plus 13 is 18. Kind of like when you did the elimination method back in Algebra 1, you would be able to figure out, maybe I could eliminate a variable. Same idea as what we're going to do here, but I just gave you an example. You can add row 1 plus row 2 and replace it with a row. All right, what else can you do? Number 3, you could do a combination of 1 and 2. I could multiply the row number 2 by 2 and then add it to row 1. So you can add them together, or you can add and multiply and divide. We could do all sorts of different things. And then number 4, we could exchange 2 rows. So that means if I want to switch these two, it could be 1, 0, 3, 0, 1, 7. I could have it be 0, 1, 7, 1, 0, 3. All right, so we could have something like that where we just switch them. What's kind of nice is that in this way it's not reduced row echelon form. If we switch it back to here, now it is. So that's why it would be kind of nice if we could switch these two. All right, so let's actually get into this and let's do an example problem. Here we go. So our example is 2x plus y equals 5 and 5x plus 3y equals 13. Now I wrote down what we're going to do in pencil. Only that way you can kind of keep it straight, and I don't have to kind of keep on telling you, you can kind of see it. I'm going to write it in a different way, and we're also going to do all this stuff. What I'm going to be doing is the row reduction method to get this augmented matrix that we're going to write into reduced row echelon form. Okay, so what I'm going to do is I'm going to try and keep these rows as color coordinated as I can. So I'm going to write this one as 2, 1, 5, I'm actually going to put this dashes in now. And I'll put the brackets in now too. Alright, so it's 2, 1, 5, and then 5, 3, 13. So the first thing I'm going to do is I'm going to add negative 2.5 to R1, negative 2.5 times R1, and add that to R2. So what I'm going to do is I'm going to take that first one, I'm going to multiply it by negative 2.5. So I'm going to take negative 2.5 and multiply it by 2, 1, and then 5. Alright, so if I do that, I should end up with negative 2.5 times 2 is going to be negative 5. Negative 2.5 times 1 is negative 2.5. And negative 2.5 times 5 is negative 10, negative 12.5. So that's going to be my new, if I distribute this all the way in. Now, why did I do that? Well, the reason is right here and right here. The negative 5 and the positive 5, if I add them together, are going to cancel out. So I'm going to add these. This is my new R1 right here. It's this one times 2.5. I'm going to add it to R2, and I'm going to leave it in R2. Okay? So I'm going to just I'll rewrite it for now, just what I'm going to do. So it's negative 5, negative 2.5, and then negative 12.5. I'm going to add that to 5, 3, and 13. Okay, so that's negative 2.5 R1. Negative 2.5 times R1. So now I'm going to add these two together. And then I'm going to put that in my second row. So my second row is going to look like this. Negative 5 plus 5 is going to be 0. Negative 2.5 times 3 is going to be 0.5. And negative 12.5 plus 13 is also going to be 8.5. Alright, and now I'm only changing that row. The other row I'm going to leave what the original was. So even though I did all this work here, I'm going to keep the original, the 2, 1, and 5. Okay, so what we're going to do is I'm going to take, and how I write this is going to be negative 2.5 R1 plus R2, and that's going to go in the R2 spot. R1 is row 1, R2 is row 2. So I'm doing this stuff, and I'm going to replace R2 with that thing, which is what we did. Negative 2.5 times R1, we got this one. We added to R2, and we put it in the R2 spot. Alright, so now what I'm going to do is I want to get this number to be a 1. Right? So if I take R2 times 2, 0.5 times 2 is going to be 1. So that means I'm going to do 2 R2, and that's going to go into the R2 spot. Alright, so I will use the blue marker. Multiply all this by 2, and I should end up with the first part should be 2, 1, 5. Right? The top row 1 has not changed. And then the second row has changed. 0 is still going to be 0. 0.5 times 2 is 1. 0.5 times 2 is also going to be 1. And then I put my augmented part in there. Okay, so now the next thing I'm going to do is I'm going to add the negative 1 times row 1 to row 1. Or negative 1 times row 2 to row 1. If I add these two together, that will become a 0 right here. Really kind of handy. So that means what I'm going to do is I'm going to take negative R2, add R1, and that's going to go in the R1 spot. Okay, so let's do that. Add these two together, or in this case, I'm just going to subtract. Right, multiplying by negative 1, same deal. So I'm just going to subtract these. So it's going to be 2 minus 0 is 2, 1 minus 1 is 0, 5 minus 1 is 4, and then I still have 0, 1, and 1. 0, 1, and 1. Okay. And then we've got that. And now it's really close to reduced row echelon form, except this is a 2. So the last thing it says is 0.5 times R1, or I can take 1/2 of R1, and I'm going to put that in the R1 spot. So I don't have to do anything with R2. Divide this by 2, and I should get 1, 0, 2. And then row 2 should be 0, 1, 1. Okay. And then that is our reduced row echelon form. And that means that 1x equals 2 and 1y equals 1. So that would be our solution matrix. Okay, so that is reduced row echelon form. Good luck.